combine like terms, LT. And in addition to that, we're going to get all of our x's, again, in quotation marks, to one side, because it's just a variable. Steps 2 and 3 in this process are known as the addition principle and the multiplication principle. And that, my friends, right there is what we call the 3-step process to solving any and every linear equation in math. You're smiling. You liking this?
Yep, it's great.
Yeah? You don't have to hold that phone?
Yep.
Nice. Nice.
Backwards though.
You guys, you want some story time, or you want to just do math?
What's the word at the end of multiplying a number? A?
A?
Get rid of fraction.
By multiplying every term
Every term.
by the LCD. Sorry.
Every term by LCD.
Mm-hmm. Story time or math? What do you want to do?
Let's do story.
You know, I have carpet squares and vanilla wafers back there. We could just all like kind of curl up and I could sing to you. We could go like kindergarten. You know what I'm saying? Yeah? Nap time. Okay. Story time.
Let's
Preface story time by telling you something interesting. Did you know that you talk to yourself? Not even out loud. Most of your self-speak is inside your head, right? It's quietly to yourself. How many people in here understand that you do talk to yourself quietly in your head? Yeah, everybody does. It's called self-speak. A lot of research has been done on self-speak. And they've discovered that over 85% of what we tell ourselves is
False.
Negative.
negative. That sucks. Negative. Okay? Not me. Not me. No, man. So, I flipped that script. I'm a huge fan of overcoming weakness. About a year ago, in May, I stopped swearing. Now, if you're sitting there right now and you go, "Oh, Brother Rich, we heard you swear in Zoom." Oh, that was over a year ago. I'm sorry. I told you, man, I can't help myself. A year ago. That's the old me, you know? I changed. I'm a changed man. Okay? And, and you could say, "Well, Brother Rich, I heard you say pissed in class." Pissed is not a swear word. And if it is for you, you got way bigger problems than me. So, I'm saying. So anyways, no, you know, one of the things I love about overcoming weakness is it's the battle of the mind, you know? I mean, the greatest battles you will ever fight in your lives will be between your ears, okay? Most likely not on a battlefield with guns and, you know, ammunition and mortars and all that. The greatest battles you will fight are between your ears. It's the battle of the mind. Overcoming weakness is kind of fun because, you know, I grew up in an environment where everybody swore. My mother called me the F word on a regular basis, and she's 85 years old. And, you know, she gets on the phone, she calls up, and, have I told you this before? Yes or no? You know, I'm driving, I got her on Bluetooth, you know, and she's dropping the F-bomb and swearing like a sailor. And, you know, I got my 3 youngest kids in the backseat. I'm like, "Mom, stop!" You know, she's like, "Oh, I don't give a bleep. You know, they hear more bleep in school." And, you know, she's just, "Oh, sorry, kids. I take her off Bluetooth. I just had to talk to her in my ear." You know, it's like, "Just stop, Mom. You're too much, man." You know?
You mentioned someone else that was present on the first game. I don't know if you mentioned your mom.
That's my mom. And when I went on a mission, I didn't swear for 2 years. I think that was a gift from God because somehow I just didn't swear for 2 whole years. But I got back and got so pissed off, I lit up a whole carton of swear words. And then I had a carton a day habit, you know what I mean? I was so upset and everything. Light off about 100 swear words, you know what I'm saying? But since May, I haven't said any. Pretty good. What I like is, you start to get upset, you start to think you have to redirect your mind, you know? So we talk about self-speak, and you can turn that ratio around of self-speak. You can get positive with yourself. You know? You can start to fight that, and when you start to say something to yourself like, no, you're no good, or you can't do that, so you're like, fetch you, you know, go to H, and I don't mean heaven, you know, like, get out of there, man, you know, get out of my head, okay? So when you hear me tell stories in this class, and you're like, man, Brother Rich really likes himself. You're not right, I like myself, okay? Because I've taught myself to like myself, you know? I'm not into humility, okay? That's somebody else's problem, okay? You know, I believe in who I am. I believe in my capabilities. And I got to tell myself every day that I can succeed. There are a million factors coming at me all the time from all kinds of directions that say, you're not going to do this, you can't do this, you're going to fail, you know? I have to tune it out. So that right there, I'm going to tell you a cool story about that right there. And if you think, man, Brother Rich always tells us the good stories, you know? Like, does he really think he's all that? No, I don't think I'm all that, but to a degree I do, because that's what I tell myself. And that's what you got to tell yourself. I'll give you an example. I got a buddy named Steve. Steve and I went to high school together. Steve claimed to be my best friend. I had better friends than Steve. But when we went on missions, he wrote me a letter and he apologized. And hey, man, you're my best friend. I always screwed with you, and I'm sorry. And the way he screwed with me is Steve was a ladies' man. And every girl I ever liked, Steve would always move in on her, you know? Dude, you are such a dirtbag, you know? Steve and I are very close. We've remained close throughout our lives. We're like brothers. And if you lined up 100 boys our age back when we were 17, and Steve was in that lineup, you wouldn't even notice him. Right? You might even think he was homely. But Steve was very positive. You know, positivity is attractive. You know that? People who are positive are attractive. You know, you might not feel like you're all that on a physical scale, or that you were, blessed by God with all the, physical good looks that other people are. But I'll tell you straight up, Steve Elder, that kid, he had any girl he wanted in school. And like I said, in a lineup of 100 guys, he was not all that, okay? But girls loved him. And positivity. So if you flip that script where 85% of what you tell yourself is good, guess what you start doing? You start telling other people good stuff about themselves. Because see, you keep telling yourself, I rock, I'm good, this is great, this is a good day, I'm grateful, this is awesome, And you see other people like, wow, you look awesome today. Hey, what's going on? I heard something really cool about you recently. Is it true that you got an 8 on your math test? And you're like, yeah, man, yeah. And you like being around people like that. And pretty soon you fall in love with somebody like that, because you could live with somebody like that, because that's a good person to spend the rest of your life with. Right? Now, reality, I'm going to tell you a cool story about my life. I've told you a few. I'm going to tell you another one. And if you're like, Brother Rich thinks he's all that, I told you, yeah, sure, I think I'm all that, but I also know realistically, okay, that even if you're Steph Curry, you miss 6 out of every 10 shots you take. Steph Curry. You know who Steph Curry is? If you don't know who Steph Curry is, Google it and, get a life and just fetch and spend some time.
He dumps a couple noodles.
What was that?
He dumps a couple noodles because it's Steph Curry.
The Chef Curry. Okay, so let me tell you. Steph Curry, considered the greatest pure shooter in the history of basketball, he misses over 60% of the shots he takes on a regular basis. So over half of the shots he takes, he misses. The dude is as cocky gets. Okay? He has to be. I told you I have a little girl that plays ball, right? And she's a pure shooter. Great shooter. Her biggest weakness? Her head. Ugh. It's super hard for me because I can train her in all kinds of stuff in basketball. I'm a great coach. I'm really good at teaching you skills. And I can motivate you and all that stuff, but I can't train your brain. That's you. You got to do that, you know? I'm always giving her tips on how to train her brain. But man, she misses her first shot in a game, and I can see her body language, her shoulder slump. You know, she'll cock her head back, oh, you know. I can see her kind of look exasperated, you know, cocks that head back, oh, you know. I'm just like, dude, don't go there. You know, let it go. 6 out of 10, you're missing. She actually has a higher shooting percentage than Steph Curry, okay? And, you know, she's hard on herself. Okay. Story about that. Year is this? Okay, 15 years ago, I sold my first company. And all my buddies were like, Rich, what are you going to do now? We know you, man. You got something brewing. What are you brewing? I'm like, I'm going to write a math book. They're like, what? That sounds lame. And I'm like, I know. It sounds lame. I'm not excited, but I'm going to write a math book. I said, why? And I said, listen, man, I've been doing this for a long time. I said, I've never in my entire life seen a math book that was good. Okay? Period. And what constitutes a good math book to me is that you as a student can pick it up and learn from it. Okay? That's what constitutes a good math book. But you look at math books and they're so cluttered. They have so much information on them. Okay? And you just can't learn from them. They're overwhelming, and it's just like, oh, it's like somebody just threw up all over the pages, you know? And it came out as numbers and some letters. It's like SpaghettiOs, but it's like variables, you know? And so the bottom line is, I was like, dude, I can kill this. I can write a better math book than anyone that's out there. Now, 15 years ago, well before the pandemic, ebooks were just starting to catch a little bit of, not even popularity as much as a little bit of momentum. And I mean a little bit of momentum. And so, and you were pretty young 15 years ago, so you don't remember this, but ebooks are way more popular now. You know, the Kindle really took off a decade ago, but 15 years ago, not so much. So all the sales reps for the publishing companies would come and knock on that door back there, my office. And the reason they came to knock on my door is because, you know, if they go and they visit you and they convince you to buy their book, how many books do they sell? One, right? Just you. But if they convince me to buy their book, how many books do they sell?
One.
Hundreds. Because I'm going to make all my students buy their book. So it's just smart, you know, macroeconomics, you know, it's the, you know, scalability. They're scaling this much bigger. And so on this semester that I'm writing my own book, as always, they come each semester, they knock on my door. There's 3 publishing companies at that time, 3 major players in the United States. Prentice Hall, Addison Wesley, McGraw-Hill. You heard of any of those? Okay. And they're usually on the spine of your book. Now, Addison Wesley and Prentice Hall had a merger a number of years ago, and they became Pearson. And so on the spine of your book now you see Pearson, and that's Addison Wesley and Prentice Hall that came together, which is a pretty big deal at the time because those companies were huge in and of themselves. And Prentice Hall was the biggest of all 3. So these reps, they come from these different publishing companies, and they're like, hey, what book are you using this semester? And usually I'm like, I'm using Toby and Slater, or I'm using Bittinger. These are the names of the authors. And, you know, like, oh, well, we've got this new book by Sherry M. Messersmith, and she just does a wonderful job of outlining all of the details of, you know, differential equations. And you're like, bleh, bleh, bleh. SpaghettiO my butt, okay? I mean, it's all a bunch of garbage. I don't even want to look at it. And so you go in my office anytime, there's a bookshelf in there, and there's all these books in there. And it's just free math books they bring by for me to, you know, maybe I'll buy it someday. Right? No, I'm not going to buy it, dude. And so this particular semester, I tell them, I'm not using a math book. What? What? I mean, it was crazy, the reaction. Like, how could you teach a class without a math book? I'm like, I'm writing my own. You're writing your own? Well, can we connect you with our publishers? And I'm like, no. I'm like, what do you mean no? And I'm like, I'm not done. I've got like 3 of my 8 chapters done. I'm like, I'll get in touch with you when I'm ready. But, you know, I got to have a good product before I send it to the publishers. Well, one of them didn't listen to me. He gave my name and number to his editor-in-chief, whose name was Paul Murphy with Prentice Hall, the largest publishing company in the United States at the time.
Nice.
And Paul Murphy called me. Now, Paul Murphy was from New York City, and he was total East Coast attitude, right? Talk fast, insult you, you know. And so he gets on the phone with me, and he's like, hey, I'm telling you right now, if you want to get published in the developmental math world, it's the most saturated market in college education, and you better have something super unique, or no one's going to publish you. And he's going, and I'm like, hey, stop. And it goes silent for a second. I'm like, you called me. Good point. Okay, so what do you have? I'm like, well, I can email it to you. So I email him a few chapters. 48 hours later, Paul Murphy was sitting in a restaurant in Idaho Falls with me. Flew in from Boston. Most saturated market in the world. Better have something unique. And he flew all the way out here. You know why he flew out here? That right there.
Because he forget about it.
He's a bad boy. Listen, this right here. This is really cool. This right here is everything you need to know for the entire chapter 2. Everything you need to know. Class dismissed. I'll see you in 2 weeks. I'm kidding, but it is everything you need to know. But what we're going to do is every day we come here for the next 6 class periods, we're going to write that in our notes. And you're like, I wrote it last time. I don't give a fetch. Because you got to have it memorized for the test because it's everything you need to know. You have to have this process ingrained in your brain because it's going to apply to every problem we do for the next 2 weeks. Yeah.
So how come the school doesn't use your method?
You're stealing my thunder. Hold on.
Sorry.
No, you're good. So everything that we cover in chapter 2 is a solved problem. And so they all have equal signs. So remember, everything in chapter 1 was a simplified problem. Everything in chapter 2 is going to be a solved problem. And so what Paul Murphy loved was, he's like, I've never seen anything like this. You can teach an entire chapter with just that. And he loved things like 2 types of problems in all of algebra, solve and simplify. And he loved things like the definition of a term, which helps you throughout all of your algebra to understand the basic component that you're working with, like the basic unit of measurement, a term. Well, you're right. Look at your book right now. Whose name's on it? Doesn't say Llewellyn, right? And that's the rest of the story. And we'll go that direction another day, but not today. We don't have time. But you get my book every day on that board, okay? And you're like, that's a cop-out. It's a good story, but there's more to it. So what I want you to do right now, I want you to just drop your pens and pencils, and I want you to just understand the number one tool we use in the solve realm is what's called the balance rule. Now you are familiar with the balance rule. I start writing up here, you're going to know it. Whatever I do to one side of an equal sign, finish it for me. I must do the exact same, you might not have been that precise, to what?
The other side.
The other side, exactly. So you know this rule. And this is a universal law. God obeys this law. Physics obeys this law. All the sciences obey this law. In fact, we could draw a physics component here. If I have a 5-pound weight on a scale, here's my little fulcrum, and I have another 5-pound weight over here, and we'll pretend that that's perfectly equal here. There we go. Now, okay, and I throw a little 2-pounder right there. What's going to happen? Going to sink to what? To the left, okay? But if I hurry and I throw a little 2-pound weight over here, what's going to happen?
It's gonna balance out.
Yeah, it's going to balance out. But if I take away this 5-pound, what's going to happen?
It's gonna go right.
Yeah, it's going to drop to the right. But if I take away that 5-pound, what's going to happen? It's going to balance out. And so that's the balance rule, right? And it says whatever you do to one side of the equal sign, you must do the exact same thing to the other. So in math, here's the deal. If I have 23 minus 2, I get 21. Does 21 equal 23?
No.
No, it does not. But if I subtract 2 from the other side, doing the exact same thing, 21 equals 21. They remain equal. They remain the
Same.
same. Try to say same with a whistle. 1, 2, 3.
Same.
All of you.
Same.
It's kind of fun to watch you do that. Okay. If I divide this side by 7, I get 3. Does 3 equal 21?
No.
No. If I divide this side by 7, I get 3 equals 3. Okay, if I multiply this by 5, I get 15. Does 15 equal 3?
No.
No, but if I multiply this by 5, I get 15 equals 15. And we can play this game all fetching day long. But the bottom line is whatever you do to one side of the equal sign, you got to do the exact same thing to the other side, or it does not remain the same. You get the problem wrong. So the balance rule, just so you understand this is the number one tool in the solve realm. Okay, so when we're talking about solve problems, it's the balance rule. It's not the only rule, but it's the most utilized rule that we're going to be using. Go ahead and write that down. Go. And you're going to have plenty of time today, so write everything. I want you to write this stuff down. When you author something, your brain owns it. So I want you to write this stuff down, okay? Since you're the only person that asked, while you write for just a moment, I will give you the condensed orange juice version of why you don't use my book.
No pulp.
No pulp, man. No pulp fiction here. So, Paul Murphy flew out here and it began a bidding war. It was fun. The 3 companies all wanted to sign me to publish my book with them. They flew me to different places, met some of the other authors, met Mr. Bittinger here, who we will make fun of later on in the semester when I show you pictures of him in certain sections coming up soon. And it was cool. They spent thousands of dollars on me, took me to, great restaurants, live music, sporting venues, all kinds of stuff. And then the college informed me that anything I wrote on their time, they owned. I was like, no way. You go to any university in the nation, in the world, and as a professor, whatever you publish, it's yours. But at BYU Idaho, their eminent domain policy at the time was, you publish it on our time, we own it. Well, let me tell you something. Writing an 800-page math book is pretty painful and pretty tedious. And the problem is not only do you have to write them a book, but you have to write all these exercise sets and come up with all the solutions for them. And then you have to write test banks so they can create tests from your book. And then they don't just want one book, they want a series of books because developmental math comes in 3 courses: arithmetic, beginning algebra, intermediate algebra. And I was just writing a beginning algebra book. So I was going to be ending up writing 2,400 pages worth of books and giving it away. I'd rather pick my nose, you know what I'm saying? Like, I'm done. So at the same exact time, my next business had already taken a foothold. And that's the business I own now. And I was profiting 6 figures a year off of that business. And I was working here, and I was like, the only way I can own this book is if I write it outside of those 2 jobs. And I got kids at home, and I'm not going to do this. So I abandoned it. A couple of people here at the college really wanted to flesh out my book more. And so I gave them permission. And so a lot of the other sections have a book that they publish. And most of it's stuff that I came up with, and then they fleshed it out more. I don't have you use it because to me it's not my book. I don't love everything they did with it, and I'd rather just give you the goods on the board. And we buy this cheap old thing. This book is so old, and the only reason we buy it is for the exercise sets, so we can just do homework. And that's the crappy story at the end of it, but kind of had a cool beginning, so whatever. All right, next thing. Section 2.1. This is what we call the addition principle. So today, I want you to draw your attention back over to the far right board. Today, we are going to learn these 2 principles. This is Wednesday. this one we're going to discuss on Friday, okay? Before we dive into this a little bit more, I want to remind everybody one thing. So the last day to take the test was when? Yesterday by 11:59 p.m. Now, if you need to, desire to, want to retake the test, you have until when?
4 days after that.
Which is Saturday by 11:59 p.m. So you've got through this week into Saturday at 11:59 p.m. to retake the test, okay? All right. You guys are doing good. Now, please listen to this. If you haven't read the syllabus about test retakes, you must. Definitely before you retake a test, because it outlines the parameters by which you should approach that test. And like anything in life, we're just giving you a good, solid, sound advice on how to improve your grade. If you just run in and retake it, you probably get the same grade or worse. Okay? So take the time to look at what's in the syllabus and follow it. Okay? So today we're going to cover this. So we're working backwards in this process. We're going to start with the addition principle there. And the addition principle, well, again, I want you to drop your pens and pencils right now because I'm going to help you expedite learning super fast today. Check it out. What is x plus 3 equals 10? What does x equal?
7.
X equals what?
7.
7. Okay. And you can do that in your head. But the addition and multiplication principles are governed by the following. Okay. So we're basically going to say our governing steps, okay, to the addition and multiplication. You okay if I abbreviate those?
Sure.
Principles. Okay? All right. Number one, you gotta ask yourself who's sharing sides with x. Okay? And x stands for the variable. All right? Step number two, what are they doing to x? Okay? And we say doing. Okay? There's only 4 things we do: add, subtract, multiply, divide. Okay? It's one of those 4. And finally, you're going to take action and you're going to do the opposite of add, subtract, multiply, divide to both sides, which means you're going to obey the balance rule. Okay? So let's come over here. I know you can do this in your head, but let's do it with algebra. Who is sharing sides with x?
3.
Everybody. 1, 2, 3.
3.
3. What's it doing?
It's added.
Being added. What's the opposite of addition?
Subtraction.
Subtraction. So we're going to subtract 3, but the balance rule says what you do to one side of the equation, you got to do the exact same thing to the other side, just like this. Well, these two cancel out. Agreed?
Yes.
X is now alone. Draw your attention back to the far right board. What was the goal of solving? What's the goal? Get x alone. Okay? When it's not alone, it's not solved. When it's alone, you know the answer. 10 minus 3 is 7. What you did in your head, we can do with algebra. Why is that important? Well, when you can't do it in your head, then we can fall back into algebra. Who is sharing sides with x? 2. What's it doing?
Being subtracted.
What's the opposite of subtraction?
Adding.
So you're going to add 2 to one side, but what you do to one side, you do to the other. These cancel. X is alone. Negative 12 plus 2 makes? Negative 10. And you're done. Hard or easy?
Easy.
That's section 2.1. Now, there's the original problem. I'm just going to rewrite the original problems up here. Go ahead and write that down. Okay?
How was your Tuesday, by the way?
How was my Tuesday?
Yeah.
I think it was a pretty good Tuesday yesterday. I don't know. I live a lot of minutes in my life. Yesterday is a long ways away to me.
True.
Mm-hmm.
Hey, Rich, I'm gonna head out a little early. I have to take my wife to the dentist.
To the dentist?
Yep.
All right, man, that's cool. I got you. We're going to be
Sweet.
done here early today.
Oh,
Did everybody sign the roll? Anybody not sign the roll? No way. You know what's so funny? I saw a girl sitting out there studying her, looked just like you, but she had her head down, right? So you can see her face totally. She just looked like you, same, you know, kind of body frame, everything. And I went, she had her laptop up, and I went to slap her. Let's look up here for a second. Drop your pens and pencils. Trust me, we're going to expedite learning today. But you can't learn if you got your head down. This could be named the addition or subtraction principle. It is not. It is not named that, but it could be because we deal with both addition and subtraction in this principle. Multiplication principle. Look up here. Everybody help me out. What's 3x equals 15? What does x equal?
5.
Of course, you can do that in your head. But who is sharing sides with x?
3.
What's it doing to x?
Multiply.
What's the opposite of multiplication?
Division.
Divide by 3, divide by 3. You do to one side, do to the other. 3 over 3 is 1. 1 times x is just x. X is alone. 15 divided by 3 is 5. What you can do in your head, we can do with algebra, so that when we can't do it in our head, x over negative 2 equals negative 12. Who is sharing sides with x? Negative 2. What's it doing? Divided. What's the opposite of division?
Multiplication.
So we multiply this side by negative 2 and this side by negative 2. These negative 2's cancel. Agreed?
Yes.
X is alone. Negative 12 times negative 2 makes positive 24. And we're done. I want to re-emphasize this. 3x equals 15 is the original problem. Here we will have x over negative 2 equals negative 12 is the original problem. Okay? All right, all eyes up here. Come on. Don't look down for a minute. If that could be aptly named the addition or subtraction principle, this could be named the what?
Multiplication
Or division. But it's not. But we are applying both multiplication and division here. In your homework tonight, and it will be described as thus in your Canvas assignment, they're going to ask you to check your answers. And you go, okay, good. I always check mine. I look at the answers and make sure I do them right. Nah, that's not what they mean. They mean they want you to rewrite the original problem. So here we have x minus 2 equals negative 12. Then they want you to take the solution you got, x equals negative 10, plug it in for x, so negative 10, and minus 2 equals negative 12. And then they want you to finish this problem. We can change subtraction to addition, so I have negative 10 plus negative 2, because we always change subtraction to a form of addition, equals negative 12. These two, when combined, same or different sign? Same. Same means sum means add. 10 and 2 make 12. They're all negative, so I have negative 12 equals negative 12. And that is a true statement. And therefore, this answer is correct. Now, please, again, watch this. What if, when you did this, subtract or add 2 to each side, you accidentally forgot that that was there, and you added 12 and 2, and you said x equals 14. Possible mistake, agreed? X equals 14. So now, if you had checked this answer with 14, you would have x minus 2 equals negative 12. But then you would take that 14 and put that in, and you get 14, and you would have minus 2 equals negative 12, and you get 12 equals negative 12. Is that a true statement? No, that's a false statement, which means that your answer is incorrect, and we already knew that was incorrect. Now, do we have to do both of these?
No.
No, you check the answer you got. What I'm saying is, if you check your answer and it's true, you know you did it right. You check your answer and it's wrong, you know you did it wrong. Got it?
Got it.
Okay, now, I'm going to make you a deal. And sometimes in life, you don't know enough about what's going on to know if you got a good deal or a bad deal. For the rest of the semester, the book is going to ask you to check your answers, or require you to check your answers whenever we do a solve problem. I'm going to let you never check your answers if you do it on tonight's homework. If you do it on tonight's homework, show your work, we'll never require you to do it for the rest of the semester. Does that sound like a good deal?
Sounds good.
Yes.
Are these hard problems or easy?
Easy.
Say it with a whistle. Easy. Okay? Yeah, they're easy. Okay? 2 thoughts. 1, if you're a little behind in your homework right now, this is a great couple of sections to do extra credit. Okay? Whenever you got easy problems, get some extra points. But the other thing is, it's easy to check your answers because they're easy problems. This stuff's going to get a lot more complex. And checking your answers down the road is going to be way harder. Question, comment.
I was gonna ask, are you saying like us as an entire class or just individually?
Each individual turns in their own homework, and so each individual has to do this. Okay?
Yeah,
So-
I'm just saying like if you're gonna make the decision based on all of us doing it.
Okay, I see what you're saying. Well, at the end of the day, here's the deal. You're not going to get credit on your homework if you don't check your answers on this one. But this is the only assignment I'm going to require you to check your answers on, because as a class, we just agreed that we're going to do it on this assignment, and we're not going to do it the rest of the semester. Okay? But look at me. If you do this and you get that answer and you don't check it, you aren't getting the points. He's grading them. Blame him. Just kidding. Look up here. X over negative 2, okay, equals negative 12. What was my answer? 24. So I take that 24, I plug it in, I get 24 over negative 2 equals negative 12. 24 divided by negative 2 is?
Negative 12.
And negative 12 equals negative 12, and indeed that is true, and I am done. Check. That's all you got to do. Okay? That's everything for 2-1 and 2-2. Finish writing that down. We're going to cover a little bit about 2-3, and then we'll be done.
Do you want me to leave this here?
You're leaving really early?
Yeah.
What are you, some kind of Homo sapien?
Yeah. I can stop the video.
Don't stop the video.
Okay, I won't.
Do you, what do I got to do to stop it?
You just press the stop button right here.
Sounds pretty tough.
Yeah.
Yeah, I can do that. And I'll just put that in my office.
Okay, sweet.
Okay, cool. See you, brother. You guys got this?
Not yet.
Not yet. You got plenty of time. Take your notes. But I do like taking pictures too. I just 100. If you can only do one, you got to write it, because writing it makes you learn it. But pictures are a good. Pictures are a good backup. So if you look at your notes, you're like, I don't understand this. You can look at the board and oh yeah, makes more sense. You know. When you guys were kids, little, cell phones in class, I mean, that wasn't even an option. You know, when I was young, cell phones didn't even really exist, and definitely not smartphones with screens on them. Only thing you can see on your screen is the number you plugged in. So taking a picture with your phone was not even an option. It's such a great tool, you know. Okay, I need to erase something. Can I erase these 3 steps right here?
Go for it. Not yet.
Actually, you know what? How about I erase the 3-step process right here?
Perfect.
Got that down, don't we? Okay. But I want to draw your attention to one thing before I erase it. Please look at this, just for a minute. Just watch, all of you. Okay. The addition principle comes before the multiplication principle. We have to follow this process in order, or it doesn't work. Okay, so you got to make sure you follow in order. So we'll always do the addition principle, then the multiplication principle. Okay, that's all I want you to see. And today we're just covering those two. Okay, we'll erase this. And we're going to cover our last little bit. Okay. In section 2.3, we're going to learn how to use the principles together. Woo! It's like mixing drugs. How many people in here ever mix drugs? I don't even want to see. Nope. I should have asked that question.
I learned my mistake.
Yeah, by mistake. Okay,
Yeah.
don't do that. Okay, here's the deal. In fact, we'll take something straight from the homework here. Let's look here. Oh, perfect. 4x minus 19 equals 5. 4x minus 19 equals 5. Okay, all eyes up here. You're good, you're good.
So, Brother Rich, I'm having a hard time understanding why is that we are not reading or using your book instead of like this other.
I don't have a book.
I Oh, you don't?
School wanted
I
to
got
open
3 or
more.
4 chapters on a computer, and some of my colleagues took it and fleshed it out to other things. I don't have a book. I never finished it.
Oh, okay.
I chose not to do it because it didn't make me money.
Dang it, that sucks.
Yeah. I'm not translating the Book of Mormon. This isn't for the good of all people. It was for my financial benefit. So.
Oh, okay.
So,
For the multiplication problem here.
Yeah.
So that's the original one. X divided by -2 equals -12.
Yep.
So you just times them both by -2 to get X alone.
Yep.
And then how did you plug that in again? How did you check?
So look at this. Here's the original problem right here. Who is sharing sides with X?
The -2.
Right, so X isn't alone, there's a -2 there. What's -2 doing to the X?
Dividing it.
What's the opposite of division?
Multiplication.
So I multiplied this side by -2, and I multiplied that side by -2, because the balance rule says, if I do it to one side, I gotta do it to both.
Mhm.
-2 on the top, -2 on the bottom, they cross cancel, agreed?
Mhm.
X is now alone. -12 times -2 makes
Is-
positive 24. Got my answer. Go back to the original problem, X over -2 equals -12. Where there's an X, I put in a
24.
So now I have 24 over -2 equals -12, and I just simplify it. 24 divided by -2, I can do it on a calculator. It's -12. Yeah.
Why do we need to differentiate between addition, subtraction, multiplication, division? I mean, of course they can't mix here, but why do we need to differentiate?
Great question. We're going to do this problem 2 ways. I'll answer your question. Okay? Ready? Here we go. All eyes up here. Who is sharing sides with X?
4, 19.
Well, now we got more than one thing going on, don't we? We got 4 and we got -19. Now, I got to address one of those numbers first, and that answers your question. And the one I got to address first is in the addition principle. So I'm going to ask who's being added or subtracted to my variable X.
-19.
19. And it is being
Subtract.
subtracted, so we're going to
Add.
add. Okay? Because addition is the opposite. So we add 19 and we add 19. And this cancels, agreed? Yep. And I get 4x equals 19 and 5 make 24. So again, original problem, 4x minus 19 equals 5, just so you can see that clearly. Now who's sharing sides with x?
4.
4. It is being,
Multiply.
so you're gonna,
Divide.
what you do to one side, balance rule, you do to the other. 4 over 4 makes 1. 1 times x is just x. X is alone. 24 divided by 4 is?
6.
And x equals 6. And you're done, but you got to check your answer. So in your homework, you're going to write, everyone look up here, 4x minus 19 equals 5. Again, please don't look down. Don't take notes when I'm explaining something, because the one thing I don't love, in fact, screw don't love, I don't like. I love answering your questions, but I don't like answering a question that you didn't take the time to learn when I told you to watch and learn, because you insisted on putting your head down, and then you're like, oh, explain that to me. I'm like, I just explained it. Okay? Now, if I have to explain something twice because you truly don't understand it, happy to do it. Did you hear that? More than happy to do it. But if I have to explain something twice because you chose not to listen, that's when I want to stick one of these pens somewhere special, okay? And not on me, okay? Listen to me. What is x? What's x?
It's a variable.
Well, it's a variable, but in this instance it equals 6. So we're going to plug 6 in for x. Then I'm going to have 4 times 6 minus 19 equals 5. 4 times 6?
24.
24 minus 19?
5.
5 equals 5. Check. It is true. My answer is correct. Now, watch this. Let's just say we just randomly do something. I'm going to divide this by 4. Well, guess what? You have to divide the entire side by 4, which means you have to divide that by 4, and this by 4. You now have x minus 19 fourths equals 5 fourths. Well, I don't know about you, but I hate fractions, and that kind of sucks, you know? And so we do the addition principle first, and then the multiplication principle, and we have to, we have two numbers, we have to address one first and one second, and so we organize it by those things that are being added or subtracted are the addition principle, and those things that are being multiplied or divided are the multiplication principle. Make sense?
Yeah, one question. How do we differentiate between if we're doing this or order of operations? Because
Okay.
obviously multiplication is first order of operations, and this addition is first.
Oh, when we're what? Well, listen, what's that?
Equal sign.
We only use the order of operations in simplified problems,
That's
when it's all numbers.
I understand.
Yeah, man. Okay, it's a good question though. I mean, that's the kind of thinking It helps you organize your mind, what tools to use in what situations. I love that kind of stuff. That's great.
So this is solved, all solved.
All solved. Everything we're going to deal with in this entire chapter has an equal sign.
When we're checking, that's when we use the order of operations. That's why
It's very true what you say. When we're checking, we're using the order of operations, and this does have an equal sign,
Yeah.
but there's no variable anymore, so we're really not solving, we're simplifying it because it's all numbers. Right?
That all makes sense.
No, it's cool. Now, think about this. The story I told you, one ring to rule them all, one process to rule them all. We have covered 2.5 sections of an entire chapter in
A day.
30 minutes. Because the first 20 minutes of class, we just talked about stuff. Baloney. Okay? So, look up here. 2.1 tonight, addition principle. 2.2, multiplication principle. And 2.3, using the principles together. Now, please pay attention. In 2.3, we're doing 1 through 19 odd. There are 91 problems in 2.3. And I'm telling you right now, do not go past number 19 because 21 through 91, I don't want you to get bruised and battered. I want to teach you how to beat those up, okay? And we're going to talk about that. And that's the beginning of that 3-step process. And that's what we're going to cover on Friday, okay? Okay, I'm going to give you a choice right now. We can leave or and get out early. You are, don't feel bad, whatever you want to do. Or the other classes, I taught them a really cool thing about how to make a lot of money. You choose.
Like right now?
Yeah.
Like we can make money right now.
My next class.
Well, I'm not going to be able to
Well,
make
yeah,
money
of course.
between now and, like we did at home today.
But yeah,
My
I
wife
got
just
you.
interviewed the classes and
Yeah.
said it was really interesting, so I'm gonna say yes.
All right. So you want to learn about money or you want to stay? Or you want to stay and learn about money or you want to leave early?
Money.
Okay.
We're here to mention money. So.
Okay.
Eventually.
I'm going to erase this board. Middle board. So if you want anything off the middle board, take a picture. Just the middle board. That's all I got to erase. Okay. So the first thing I'm going to tell you before I erase this board is, who are you? There's 2 things that determine who you are. 1, yourself. There's no one like you. God made you, and there's no other combination that makes you. And God is proud of all of his creations. If you don't read the scriptures and understand that, you haven't read the scriptures. As a human being, when I create something, I'm proud of my creations. God is even more proud of his creations because they're perfect. That's the second thing you must know about yourself. You're created by God. When I talk about positive self-speak, I want you to understand that for you to realize your greatest potential in life is to understand that you are an incredible individual that no one else can be. There's no mistake. You don't have to be perfect in every aspect. You don't have to be beautiful or physically attractive or be able to sing and dance and, whatever, play sports or whatever you got. There's just whoever you are, whatever you do, you got unbelievable things to do and to offer. But know that God made you and God's real. Now, you said you're here to make money. You're not. And that's the first problem. You're not here to make money. You're here to discover who you are in light of those 2 facts. Discover yourself and discover your Heavenly Father. But while you're on this earth, you got to have money to live. But I would say that the first thing you need to do is you need to create a wealth plan. Did you hear what I just said? A wealth plan. Now, there's a difference between a wealth plan and a work plan. Most of you are going to college because you're trying to figure out what you're going to do for work. I want you to start thinking about how you're going to make wealth. You need $300,000. And you need to set a goal today, not to make $300,000, but to set aside $300,000. Now, some of you are like, holy crap, Brother Rich. I don't know how I could ever do that. I could set aside $300,000 this year, in the next 12 months. I'm 51 years old. I'm in a little different position than you are. How long will it take you to get there? I don't know. But I think you should make a goal right now that you could set aside $300,000 by the time you're 30 years old. Okay? Now, what do you do with that $300,000? I want you to go out and I want you to buy, and I'm just going to do this in a condensed version today, 6 townhomes. 6 townhomes, apartment, condo, basically 6 doors, 6 rental doors. Now, each one of these townhomes should be about $300,000 in price and value. You say, Brother Rich, I thought you were a math teacher. How do I buy 6 townhomes and each one costs $300,000 when all I have is $300,000? You borrow money. You get a loan at the bank. Now the bank is going to require you to put 20% down on your purchase. 20% of 300,000 is 60,000. But listen to this. That number isn't a tight number, so you could probably put $55,000 down, but if you're a first-time home buyer, you can put 10% down. And so on the first one, you can put $30,000 down. And on the next few, you can put $55K on each one. And it's going to add up to be pretty close to $300,000, and you're going to have, basically that's $295,000 right there, with all that put down on those. Your mortgage payment for each townhome. This townhome, it'll cost you about $1,500 a month. This is a 15-year mortgage. You can charge about $2,000 per month for rent, to rent this out. You profit $500 per month. Take all that money, plug it back into the place, pay all of them off in 10 years. In 10 years, you're 40 years old. You've paid every one of them off because every one of them rents. Do you understand this? Every one of them rents for $2,000 a month, minimum. Maybe $2,100, somewhere in that range. Your mortgage costs you $1,500 a month. You have $500 left over. You take a little bit of that money, put it in a little account for any repairs, stuff like that, for each one of these, and the rest of it you put back on the mortgage, and in 10 years you have them all paid off. 6 townhomes times $300,000, all paid off, is $1.8 million by the time you're 40 years old. $1.8 million. Now, in 10 years after you buy them, will they be worth $1.8 million? Because, you know, people have rented them, there's wear and tear, there's use on them. Will they be worth more or less?
Less.
More.
More, because they have equity.
You're a good man.
Mm-hmm.
You know what you're talking about.
Yeah.
Real estate appreciates in value. In 10 years from now, all these townhomes will be worth more than they were, even though they're used. So you won't have $1.8 million, even if this just bumps up to $350,000 in 10 years. And I got to tell you, that would be a small amount of growth in 10 years. 350, you're going to have $2.1 million in paid for assets. And you'd be 40 years old. Well, here's the other cool thing. 6 of them are now making you $2,000 profit a month because they're paid free and clear. 2,000 times 12 is 24,000. 24,000 times 6 is $144,000 a year in passive income, and you can give the bird to your job.
Oh.
Or you can keep your job. Or you can go get a dream job. Or you can do whatever the fetch you want. Wealth isn't money. Wealth is freedom. And if you don't have a wealth plan, you're going to work for the rest of your life. If you have a work plan, then you're planning to work. You need a wealth plan. And this is one example of something that you can do in your lives. And I encourage you with all my energy to build a wealth plan. I wish when I was in your seat, somebody would have told me this, because I had to figure it out on my own. Do I do this? You can fetch and bet you I do this. I got a lot of assets out there, and a lot of them are free and clear, and I'm building more. But my point is this. $300,000. You today could be sitting here going, how am I ever going to get $300,000? You can do it. You can do it in 10 years. Put your head down and bust your butt. You can set aside. I just tell you, scrape and scrimp and bust your butt and come up with that, and then put that in there. It's an amazing thing. And you know, at the end of the day, you start with one. Because the first $50,000 you get, go buy you a place, you know? And if you buy yourself a place in the way that rules and regulations work, you might even be able to buy yourself like a duplex and get 2 doors with only 10% down, because if you live in one of them and rent the other, they might sell you the whole complex at a first homeowner's, you know, loan situation. You guys have a good one. I'll see you Friday. Sayonara!
See you Friday.
Oh, I gotta stop this and take this with me.
Oh yeah, that's his phone, right?
Can't be doing this. You're good, man. Whoop.